Okay, so when we talk about limit is basically the value that a function approaches as the input approaches some value. So what do we mean by this definition? When we have an example like this, limit as, let's say, x approaches a of a certain function like this. This is the function. This becomes our function, and this is our input. So what it means is the input, that's x approaches a. When x approaches a, what will this function become? Do we get it? So that's what we mean by the value that a function approaches. So what value would this function approach when this input x approaches a? So that is what we mean by limit. Let's start taking real examples and see how everything goes. Limit as x approaches 5 of the function s squared plus 2x minus 4. Okay. When you have a question like this is rather simple. All that you have to do is to evaluate the input. So this is the function, this is the function, and this is the input. So what will this function become when this input approaches 5? So when you have a question like this, all you have to do is to do direct substitution. So we have 5 squared. That's wherever that you see the x, then you put in the 5. So 5x plus, 5 squared plus 2 times 5 minus 4. At the end of the day, we will get 31. So the limit as x approaches 5 of this whole function, corresponds to what? 31. That's basically what limit is about. Okay, now let's take a different example. Let's say limit as x approaches 2 of the function x squared minus 4 all over x minus 2. Okay. So just now I told you that when you have questions about limit, you just do direct substitution. But mind you, it's not every question that direct substitution is going to work. An example like this, let's try direct substitution and see. So we have 2 squared minus 4 all over 2 minus 2. So 2 squared is 4. So 4 minus 4 all over 2 minus 2. You obviously get 0 over 0, which is what? Undefined. The function will become undefined. But the limits of this whole function do exist. So we cannot get undefined. But the question is, what is the problem here? When you have questions like this, if the limits do exist and direct substitution do not work, these are some of the things that you have to take into consideration or ways of solving such questions. We have the first method to be factorization or simplification. You just have to do some factorization or simplify the function before you do your substitution. So we all can testify that limit as x approaches 2 of s squared minus 4 over x minus 2 can be written as this, because obviously it is difference of 2 squared. We can get x squared minus 2 squared all over x minus 2 like this. Okay, so difference of 2 squares. When you have something like, let's say, a squared minus b squared, we're going to have the difference of 2 squared as a plus b multiplying a minus b. Okay, we have x squared minus 2 squared. X squared minus 2 squared is obviously going to be x minus 2 multiplying x plus 2 all over x minus 2. Okay, and we can see that we have x minus 2, x minus 2. This can take care of this, and you have x plus 2. So everything will reduce to limit as x approaches 2 of the function x plus 2. So after simplification or factorization, this whole thing reduced to this. So when you are done simplifying, then you can do your direct substitution. So wherever that you see x, then you put 2 there. So 2 plus 2 will give us 4. So initially, it gave us undefined because we didn't simplify it. But after further simplification, this limit as x approaches 2 of the whole function is at 4. That means the limit do exist. So sometimes the direct substitution will not work. So but mind you, you can get 0. If the limit were to be 0, it was acceptable. It will be acceptable. But then if it's undefined, you can find a way to do what? To break it down, simplify it, and do the evaluations. So that is that. Okay. Let's move on to choosing a number very close to the limit. First of all, we said we can do so by doing simple factorization or simplification as we just did. So when you have limits like this too, you can do what we call close number evaluation. So you see the limit is as x approaches 2 and you will get undefined. But then when you choose a number which is closer to 2, it can help us find the limit. So this works for every limit. If the limit is giving you undefined, just choose a number that is quite closer to that particular number. So here we have limit as x approaches what? X approaches 2. So let's choose 2.0. So instead of using limit as x approaches 2, we will use limit as x approaches 2.0. So the actual example is limit as x approaches 2 of the function x squared minus 4 all over x minus 2. When we did direct substitution, we had undefined. Okay. And I'm saying that limits like this, you can just choose a number which is closer, much closer to that number. So I will choose 2.01. So instead of limit as x approaches 2, I will do it limit as x approaches 2.01 of, of the function x squared minus 4 all over x minus 2. Okay. Let's see what we get when we do this. We will have 2.01 squared minus 4 all over 2.01 minus 2. And when you punch this on the calculator, you are going to get 4.01, which is approximately 4, just like we had when we did the simplification. When you have an undefined limit and indeed that limit exists, you can either simplify the function or you will choose a limit which is closer to the initial limit. So we had the initial limit to be 2, but because it were given as undefined, we chose 2.01. So that is that. So you can use the factorization or direct simplification, or you choose a number which is close to the limit. So that is it. So 4.01 is equivalent to 4, or is approximately. Let's take another example. Let's see limit as x approaches 3 of the function x cubed minus 27 all over x minus 3. This is the limit. So let's start doing direct substitution and see what we will yield. We have 3 cubed minus 27 all over 3 minus 3. 3 cubed is 27. 27 minus 27 over 3 minus 3. This gives us 0 over 0, which is undefined. It is undefined. Just like what we just saw. But then, like I said earlier on, if the limits do exist, you can do a simple simplification, or you can just choose a number which is closer to the limit. So here let's choose number which is closer to the limit as 3.01 of x cubed minus 27 all over x minus 10. We've chosen a number which is much closer to 3.3, which is 3.01. So let's do the evaluation and see 3.01 cubed minus 27 all over 3.01 minus 3. This will give us something like 27.0901, which is approximately equal to 27. So it's obvious that limit as x approaches 3 of this function is this. But if you were to use the direct substitution, you would have gotten undefined, which is not the case. So let's try the simplification method with this. In the simplification method, we have ways of doing it when it comes to questions like this. This one you can just use the long division to divide the numerator. X minus 3 the denominator, x cubed minus 27 is the numerator. You can divide it by using that polynomial the division that we learned in SHS. Yes. So we have limit as x approaches 3 of the function x cubed minus 27 all over x minus 3. This is what we have. So can use the polynomial division. We have x minus 3 here. It is going into x cubed minus 27. And to avoid confusion, we can say x cubed plus a certain x squared. 0x squared is still 0. Plus a certain 0x minus 27. If you really remember how we did this in SHS, you would know that is exactly how we do it. So x cubed plus 0x squared plus 0x minus 27. Okay, so this is the same as x cubed minus 27 because 0x squared plus 0x does not count. It's just reducing the polynomial to the simplest form possible so that we do not have any problem when we are doing the division. So start. We have x cubed here. X cubed divided by 3 is x squared. X times x squared is x cubed. Negative 3 times x squared is negative 3x squared. And we subtract x cubed minus x cubed will be what? 0. So that one will move away. 0 squared minus 3x squared. Sorry, 0x squared minus 3x squared. It's obvious that you get 3x squared positive. And you already have these ones to here. 0x minus 7. Bring our negative sign, do our division. So 3x squared divided by x, you will get positive 3x. X times 3x, we have 3x squared. Negative 3 times 3x, we have negative 9x. Okay. So we do the subtraction. 3x squared minus 3x squared is 0. 0x minus 9, we get positive 9x minus 27. We have 27 minus 0 because there is nothing here. There is no constant here. Okay, so start again. X goes into 9x, 9. So plus 9. X times 9 is 9x. 9x. Negative 3 times 9 is what? Negative 27. At the end of the day, you get 9x minus 9, which is 0. Negative 27 minus 27 is 0 because it will be negative 27 plus 27 is 0. So we have the factors to be x minus 3 and s squared plus 3x plus 9. So this whole limit thing can be reduced to limit as x approaches 3 of s minus 3 multiplying s squared plus 3x plus 9 all over x minus 3. This s minus 3 will cancel this s minus 3. And you have limit as x approaches 3 of what is left here, which is x squared plus 3x plus 9. So this has been simplified as far as possible. You can just do a direct substitution at this point. We have 3 squared plus 3 times 3 plus 9. We have 9 plus 9 plus 9 is equivalent to 27. So that is one way of solving questions like this. Or you can just how do you call it, factorize the numerator because it is difference of two cubes. Difference of two cubes. And when we have difference of two cubes, this is how we go by it. Okay. So when we have difference of two cubes, when we have maybe a cubed minus b cubed, this is how the expression becomes. We have a minus b multiplying a squared plus b plus b squared. So limit as x approaches 3 of s cubed minus 27, which is the same as 3 cubed. Because 3 cubed is 27. So this becomes the difference of two cubes. So applying this or expressing this as difference of two cubes, you can get x minus 3 multiplying the expression x squared minus 3x plus 9 all over x minus 3. Yes, when you express this as difference of two cubes, this is what you are going to do. This will take care of this. We will come back to get our x squared minus 3x plus 9. So when we are done with this, sorry, plus. So when we are done with this, we can just evaluate our limits as 3 squared plus 3 times 3 plus 9. So that is that. So limits can sometimes be very stubborn. It's not always that you get the ones that has to do with the direct substitutions. You substitute and you go. At times you have to simplify further. And this requires some skills of what you've learned in SHS and what have you. So that is that for the limits. Differentiating functions with the first principle, you have to know this formula. Assuming you have a function f of x, y equals f of x, you want to differentiate the function using the first principle. This will give us limit as h approaches 0 of f of x plus h minus f of x all over h. So this is the formula that you need No. And sometimes to find limits, as instead of h, some books will use change in x approaches 0. They are the same thing. Of f of x plus change in x minus f of x all over change in x. You can use the h1 or the change in x or any letter that you want to use or anything that you want to represent it. But the most important thing is to get this formula. Okay, now let's start solving some examples. So, assuming we have a question like this, we are supposed to differentiate this from the first principle. F of x equals 2x squared minus 5x plus 3. We have a function like this, and we are supposed to differentiate from the first principle. All you have to do is to start putting down your formula. The f of x over x equals limit as h approaches 0 of f of x plus h minus f of x all over h. So you could see that in the formula we have f of x plus h and we have f of x. Our f of x is the question that we were given, is our question. So we have our f of x. So we will need to find our f of x plus h. Our f of x plus h will be equal to wherever that you see wherever that you see x here, you put x plus h. We will get 2 multiplying x plus h all squared minus 5 multiplying x. So we represent or use x plus h plus 3. This is our f of x plus h. This is our f of x. This is our f of x. Okay. So what we have to do is to just substitute this in the formula. So our f of x is 2x squared minus 5x plus 3, and our f of x plus h is 2x plus h all squared minus 5 multiplying x plus h plus 3. So we have our formula here. Limit as h approaches 0 of f of x plus h minus f of x all over h. Let's start doing our substitution. So with the f of x over x equal to limit as h approaches 0 of, this is our f of x plus h, the whole of this expression. We get 2x plus h squared minus 5 multiplying x plus h plus 3 minus f of x as minus this whole function. Have 2x squared minus 5x plus 3 all over. The rest is just simplification, application of the limits that we learned. So the f of x over the x will be equal to limit as h approaches 0 of 2. Let's simplify the x plus h squared. We get x squared plus 2x h plus h squared minus 5 multiplying x plus h plus 3 minus 2x squared minus 5x plus 3 all over. Let's expand the f of x over x equals limit as h approaches 0 of, we are expanding the numerator, 2x squared plus 4xh plus 2h squared minus 5x minus 5h plus 3 minus 2x squared. Negative, multiply negative 5x. This is positive 5x, and negative and positive 3, negative 3 all over h. Okay, so when we take a closer look, we see that we have positive 2x squared here, negative 2x squared here, they cancel each other. The same for negative 5x and positive 5x, negative 3, positive 3. Okay, so at the end of the day, we get f of x over x equals limit as h approaches 0 of 4xh plus 2h squared minus 5h all over h. Okay, so we can give everyone or every term its denominator. We can have 4xh over 4xh over h plus 2h squared over h. We are just sharing their denominators for them. So this will take care of this. This will leave one here. This will take care of this. So the f of x over x equals limit as h approaches 0 of 4x plus 2h minus 5. Okay, so when we are at this point, then we evaluate our limits. So the f of x over x will be equal to, and we put in the 0. So wherever that we find h, we put in 0. 4x plus 2 times 0 minus 5. This will go to 0. So it will be left with 4x and negative 5. So the f of x over the x, that function will give us 4x minus 5. So that is that for the example 1. So it's rather simple. All that you have to do is to get your f of x, which will be given in the question, and your f of x plus h, which is done pretty much easier. So that is that. Then you do your simplification by applying some tricks in algebra, and you are good to go. Okay, so let's move on to the second example. The second example says we should differentiate this particular function. F of x equals s cubed minus 4 using the first principle. So you know that for the first principle, the f of x all over x will be equal to limits as h approaches 0 of f of x plus h minus f of x all over h. So we need f of x plus h and f of x. We already have our f of x plus h here. Sorry, f of x here. So we find our f of x plus h. So f of x equals s cubed minus 4. So our f of x plus h will be equal to, so wherever that you see x, you put in x plus h. So x plus h cubed minus 4. We have this and this. Just bring them here and we do a simplification. So f of x is s cubed minus 4 and f of x plus h is x plus h cubed minus 4. So f of x all over x equals limit as h approaches 0 Okay, so substitute what we have over there. This is our f of x plus h. Put it here. X plus h all cubed minus 4 minus f of x, which is x cubed minus 4 all over h. So let's simplify what we have there. So the f of x over x will be equal to limit as h approaches 0 of, when we simplify this, we get s cubed plus h cubed plus 3s squared h plus 3x h squared minus 4. And we expand this one minus s cubed plus 4 all over. We have s cubed here to take care of this. We have what again? Negative 4, positive 4. So at the end of the day, we are going to have your the f of x over x equals limit as h approaches 0 of h cubed plus 3s squared h plus 3x h all over h. Let's do the simplification. Get h squared plus 3s squared plus 3x h here. Okay, then we evaluate the limits. So the f of x over the x will be equal to 0 squared. We are evaluating the limit h approaches 0. So wherever that we find h, we put 0 there, plus 3x squared plus 3x times 0. This will be 0. The whole of this will go to 0. Therefore, the f of x over the x will give us 3x squared as our final answer. Okay, so that is that. Let's solve one more example and close the curtains on derivatives as first principle specifically. Okay. For example 3, we have f equals 1 over x. We are using the first principle to solve this. Okay. Without wasting much time, we know that f of x plus h will be equal to 1 over x plus h. We put our formula down. The f of x over x will be equal to limit as h approaches 0 of the function f of x plus h minus f of x all over h. Our substitution begins. Limit as h approaches 0. We have f of x plus h, which is 1 over x plus h minus f of x, which is 1 over x all over h. So we can say that this will give us limit as h approaches 0. We're going to simplify the numerator. When we simplify the numerator, we will get x minus into bracket x plus h all over x multiplying x plus h. And we bring our h. So this is what we are going to get. Okay. So we have our x minus x, we are expanding this, x minus x minus h all over x into bracket x plus h all over h. This will take care of this. Then we get negative h over x multiplying the expression x plus h all over h. Let's write it at different surface. We get so this is how the expression becomes. Because it was negative h all over x multiplying x plus h divided by h. Okay. And we can rewrite this as limit as h approaches 0, negative h all over x multiplying x plus h times 1 over h. This will take care of this. And we get limit as h approaches 0 of negative 1 over x multiplying x plus h. Further simplification will yield limit as h approaches 0 of negative 1 over x squared plus x h. So this is what we have now. Then we can evaluate SH. Okay. So this is what we have now. So now you can evaluate the limit here. So the f of x over x equal to negative 1 over wherever that we see which we put in 0 plus x times 0. So this will go to 0. And at the end of the day, we have 1 over squared like this, which is the same as negative x to the power negative. Final answer. That is that. Thank you for watching the video. See you next time. Bye.